Hello, friends, and my dear students. I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is set 1 of 10 good problems on the chapter of playing with numbers, which I have just completed in the playlist CBSC Maths 8 RS Agarwal. So, this series of videos consists of 10 good problems that I solved, and these problems are based on HOT, that is high order thinking problem. These problems are comparatively little harder from the problems that I solved from the textbook of author R.S. Agarwal. So this video is part of the playlist Maths 8 HOT. HOT stands for high order thinking, where I come up with 10 good problems for on every chapter as and when I complete them in the playlist CBSC Maths 8 RS Agarwal. Uh, these set of problems will give you a good evaluation of your understanding of the chapter concepts, and it is recommended that you solve these problems only when you have completed the chapter and have studied them thoroughly and solved quite a few problems from your textbook or any other reference book. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving our 10 good problems on the chapter of playing with numbers. Okay, so I have my 10 good problems set on the left hand side, and on the right hand side I will solve the problem. I hope you can properly see the question paper problems. The fonts are big enough that you can see read it properly. The PDF of the problem set, the link of the PDF of the problem set will be given in the description below, from where you can check it out. And it is always recommended that you try to solve the problems yourself first, and only if you are stuck and if you cannot solve the problem after multiple attempts, then you can see this solution video. So let's start solving the problems. The first problem says that 1x 3 by 6 is a 5-digit number where x and y are digits and y exceeds x by 6. If this number is divisible by 18, then the value of y by x is. Okay, so the number given is 1 x 3 y 6. So this is a 5-digit number, and it is also given that y exceeds x by 6. So y is equal to x plus 6, where x and y are digits, that is, they have values from 0 to 9. Now, if this number is divisible by 8, now it is given that this number is divisible by 18. Now, 18 is always when you are given any number divisible. If you are given the fact that the number is divisible by any number and that any number is not a number between 2 to 11, then always try to factorize that number into factors where the factors do not have any common factor. So in this case, I will not factorize it as 6 into 3, because there is a common factor between 6 and 3, which is 3. So never factorize the number like this. Another choice is 9 into 2. That is the correct choice of factorizing the number 18. 9 into 2, which 9 and 2 do not have a common factor. So the concept is, when a given number, this number is divisible by 18, it also means that the number 1x 3 by 6 will be divisible by both 9 and 2. That is, it will be divisible by all the factors of the number 18. Okay. Now a number will be divisible by 2 when the digit at the ones place or units digit is even, which is already the case as we can see, the units digit in the given number is 6. So we need not check it is already this number is already an even number, so it will be definitely divisible by 2. So we need to just check whether this number is divisible by 9 or not. So to check that, we must have the sum of the digits of the number must be divisible by 9. So this is the sum of the digits of the number. This must be divisible. This must be divisible by 9. Okay. Now this implies we have this is 10 plus x plus y. This number will be divisible by 9. Now it is given that we have y equals to, this fact is given, that is y exceeds x by 6. So y must be equal to x plus 6. So if we substitute, we can say then that 10 plus x and y is, we know, x plus 6. We can say x plus 6 is divisible by 9. So this implies that 16 plus 2x is divisible by 9. Now what can the value of x be such that 16 plus 2x is divisible by 9? Now the next number after 16, now x can have values from 0 to 9. The next value that is so x 16 plus 2x will definitely be greater than or equal to 16. So what is the next number after 16 which is divisible by 9? That is 18. So hence this will imply what is the question? Then the value of y by x is, okay. Now we need to check whether there is only one value of x such that 16 plus 2x is divisible by 9, or there are multiple values of x such that 16 plus 2x is divisible by 9. Since it has asked to find, the problem has asked to find the value of y by x, and there is only one choice. All the choices have single value, meaning there will be a single value of y by x, which also means that there will be a single value of y by x. So from here we can clearly say that 16 plus 2x must be equal to 18, because the next number after 16 which is divisible by 9 is 18. Okay, so this implies 2x is equal to 18 minus 16, which is 2. This implies x is equal to 2 by 2, which is 1. So x is 1. Okay. Now this implies, we know that y is equal to x plus 6. So this will imply y equals to x plus 6. Y will be equal to, we know x is 1. 1 plus 6, which is 7. So this will imply y by x, we are asked to find the value of y by x. So y by x will be 7 by 1, which is equal to 7. So this is the value of y by x. So the number, the digits x is 1 and the digit y is 7. So the correct choice is A. The correct choice is A. So after solving the problem, I will pause for a few seconds so that you can take a screenshot of the solution for future reference. Okay. Okay, let's solve question number 2. Question number 2 says the sum of any two-digit number, a sum of any two-digit number AB and the number BA by reversing its digits is completely divisible by P and the quotient is Q. Then the value of P plus Q is. So it is saying that there is a number, two-digit number AB, and the sum of any two-digit number AB and the number BA by reversing its digits. So the number obtained by reversing the digits of the number AB is BA, and their sum, it is saying that their sum is completely divisible by P and the quotient is Q. So this will be equal to something like P into Q, where uh, P is the divisor and Q is the quotient. So when it is saying that the sum of any two digit number AB and the number BA by reversing its digits is completely divisible by P and the quotient is Q, it means that the number is basically equal to P into Q. Now we have to find basically P and Q, and from P and Q we have to find the value of P plus Q. Now the choices are given in terms of A and B, except A where it is a constant value 20. Now AB plus BA, if, using the generalized form of numbers of two digit numbers, we can say that what is AB? AB is 10 into A plus B. And what is BA? BA is 10 into B plus A. We have equals to P into Q. Okay, this implies if I add the A terms and the B terms, I get 10A plus A, and I have 10B plus B is equal to P multiplied by Q. For some P and Q, we don't know yet what is P and Q. If I further simplify the left hand side, I get 11A plus 11B is equal to P into Q. After further simplification of the left hand side, I get 11 into A plus B is equal to P multiplied by Q. Now this implies definitely P and Q, either P will be 11 and Q, so this implies we can clearly see that P will be 11 and Q will be A plus B, or we can say P is A plus B or Q equals to 11. Anyway, the P and Q, we can say that P and Q is equal to 11 and A plus B, or we can say that P and Q are A plus B and 11. So irrespective of the value irrespective of whether P is 11 or A plus B, the sum of the value of P and Q will be same. So we are asked to find the value of P plus Q. So this implies P plus Q will definitely be equal to 11 plus A plus B. This is the value of P plus Q. So the correct choice is answer D. Okay, let's solve problem number 3. It says that if AABB is a 4-digit number and also a perfect square, then the value of A plus B is, the number is 4-digit number AABB, where the first two digits from the left hand side is the same digit A, and the last two digits are the same digit B. It is saying that this number is a perfect square. Then what is the value of A plus B? Okay, now using again the generalized form of number, we can say that this is equal to we can say that 100 multiplied by AA. AA is the number formed from the two digits AA, plus we can say this is equal to BB. Now I hope this is clear. I hope this is understood that any 4-digit number, let's say consider any 4-digit number XYZW, where X, Y, ZW are some digits, that is their values from 0 to 9. This number can be, if we expand this, we can say that this is equal to XY multiplied by 100 times XY plus the number ZW. So the 4-digit number AABB will be equal to 100 into AA plus BB. Okay. and also perfect square, then the value of a plus b is. Okay, so now this is equal to, if I further expand the numbers AA, uh, okay, so AA, 100 into AA. Now what is BB? If I expand the number BB using the general form, I can say this is equal to 10B plus B. This is equal to 10B plus B. Mm, and if I expand the number AA, I can say this is AA is the number after expansion, that is the general form of the number AA is 10A plus A, and we have here 10B plus B. So perfect square. Okay, so this is equal to, this is equal to 1000A plus 100A plus 10B plus B square. Perfect square. Then the value of A plus B is, um, is a perfect square B. It's a 4-digit number. The value of A plus B is, I'm not sure how to proceed from here. Uh, Not getting, can this general form be simplified in a form where we can say what can the value be, considering the fact that this number AABB is a perfect square. Now, is a perfect square. Plus B. Now, uh, one thing to note is that, okay, 81. Then the, no, I'm sorry, I don't know from here how to proceed. I will put a question mark, and I will come back to this question later on. I cannot think of anything how to proceed from here. Anyway, I will move on to the question number 4, and perhaps I will come back to this question later on if I will give a second try. So let's do problem number 4. A 5-digit number xy235 is divisible by 3 such that x plus y is less than 5. So the number is xy235. This number is divisible by 3, which means that the sum of the digits must be divisible by 3. Okay, such that x plus y, it is given that x plus y is less than 5. Then possible values of x and y. We are asked to find the possible values of x and y. Now this this number is divisible. It is given that this number is divisible by 3. So this implies that the sum of the digits must be uh, the sum of the digits must be divisible by 3. This implies x plus y plus 10 is divisible by 3. Now it is also given that x plus y is less than 5. Now what values we can consider for x and y such that x plus y will be less than 5, as well as x plus y plus 10 will be divisible by 3. Now if let's now we can first we must see what can the value of x plus y be such that x plus y plus 10 it will be divisible by 3, where we know that x plus y is less than 5. uh, this implies that x plus y equals to, it can be x plus y is less than 5, so can it be 4? 4 plus 10 is 14, which is not divisible by 3. So x plus 4 cannot, x plus y cannot be 4. X plus y, can it be 3? No, because 3 plus 10 is 13, which is not divisible by 3. Can x plus y be 2? So 2 plus 10, 12 is divisible by 3. So x plus y can be 2. Can x plus y be 1? 10 plus 1 is 11, which is not divisible by 3. And can x plus y be 0? No, because 0 plus 10 is 10, 10 is not divisible by 3. So the only mm, option, the only possibility of so whatever the value of x and y be, we must always have x plus y equals to 2. Now based on the fact that x plus y by 2, we can choose the values of x and y. So this implies what are the possibilities? X cannot be 0. Please remember that x is the leftmost digit. In a number, we never have a 0 in the leftmost digit. So x cannot be 0. So x has to be minimum 1. So if x is 1, we can have y equals to 1, and y can be 0. Another possibility is x is 2 and y can be 0. So in both the cases, we are having x plus y equals to 2. So these are the two possibilities, that x equals to 1, y equals to 1, and x equals to 2 and y equals to 0. Hence, the correct choice is B. The correct choice is B. B is the correct choice. Okay, let's do problem number 5. If for a number n divided by 5 leaves a remainder of 4, the ones digit of the number n is. It is given that n divided by 5 leaves a remainder of 4. Now, one concept you must remember that any number, any number, any number n, if it is divided by a digit, let's say a, where a is a digit, if n divided by a a remainder leaves a remainder b, where b is also an integer, leaves a remainder b, then this will imply that units digit sorry let it so the one concept is that for a number x, y, z. I'm considering a three-digit number. It could be one-digit number, two-digit number, three-digit number, any number of digit of number. I'm just for the sake of explanation, I'm saying let's consider any number x, y, z. Uh, x, y, z, x, y, z divided by a, where x, y, z are digits. They have values from 0 to 9. If x, y, z is divided by a is also a digit, leaves a remainder, leaves uh, leaves a remainder b, where b is also a digit. This will imply that z divided by a also leaves the remainder b, because the number xyz when divided by another digit, the remainder, whatever the remainder it will have, will entirely depend on the units digit of the number. This you can verify this. You can verify. No, sorry. Mm, no. This will only work for 5, not divided by a, but it will only work for divided by 5. I'm sorry. So any number xyz, if you divide the number by 5 and it leaves a remainder b, whatever that b is, obviously b will be something less than 5. It could be 0, it could be 1, 2, 3, or 4. So if it is b leaves the remainder b, it actually means that the units digit of the number, that is z, when divided by 5 will also leave the same remainder of b. Remainder b, because this is this fact is because xyz is equal to, I can write it as 10 into x y, 10 into the number formed by the two digits x y plus z. Now 10 into 10 into the number x y will always be divisible by 5, and so the remainder when the remainder of xyz when divided by 5 will actually depend on the remainder when z is divided by 5. Okay, now back to the question. So we can say that if the n divided by 5 leaves the remainder of 4, we can obviously say that the units digit of n when divided by 5 will leave a remainder 4. And what is the question? The question is, if for a number n divided by 5 leaves a remainder of 4, the ones digit of the number n is. It has asked about the ones digit of the number n. So so from here we can say that ones digit of n when divided by 5 leaves a remainder of 4. Now, so we need to now we need to now find what can the ones digit of 9 of n be, because that digit when divided by 5 leaves the remainder 4. So we have to now find a digit which when divided by 5 leaves a remainder 4. So if ones digit of n is x, this implies that x divided by 5 leaves remainder 4. Now what can the digit x be such that when it is divided by 5 it leaves a remainder 4? This implies x, what are the possible values of x? X can be 4, x can be 4. Now what else x can be? Can x have any other value, any other digit such that when it is divided by 5 it leaves a remainder 4? Yes, it can be. What will it be? It will be just 4 plus 5, that is 4 plus 5. So that is x is, this implies the possible values of x, which is basically the ones digit of the number n, is 4 and 9. So the question is the ones digit of the number n is 4 or 9. So the correct choice is D. D is the correct choice. Okay, let's do problem number 6. It is saying that 56x, there is a number 56x 3 to 2 is divisible by 18. This number is divisible by 18. And as I discussed in regarding the problem 1, that when it is given that a number is divisible by some number and that number is not between 2 to 11, we have to factor that number. In this case the number is 18. We have to factor the number such that the factors do not have any common factor, that is the factors will be 2 and 9. So the given number is divisible by 18, and 18, it will mean that the given number must also be divisible by both 2 and 9. Now we can clearly see that the given number is even because the ones digit is 2, which is even. So definitely this given number will be divisible by 2. So we just need to check that this given number is divisible by 9 or not. So we have to find the value of x such that this given number is divisible by 9. Now this implies 5, 6x 3 2 2 is divisible by 9. Now we know that a number is divisible by 9 only when the sum of its digit is divisible by 9. So this means 5 plus 6 plus x plus 3 plus 2 plus 2 is divisible by 9. Now this implies if we add the numbers, we have 11 and 14 and 16 and 18. We have 18 plus x is divisible by 9. So 18 plus x has to be divisible by 9. So what can the values of x be? X can be 0 because 18 plus x is 18. 18 plus 0 is 18, which is divisible by 9. What else can value of x be? X can be 9 because then find the value of x. So this implies that the possible values of x will be either 0, If x is 0, then 18 plus 0 is 0. 18 plus 0 is 18, which is divisible by 9. Another possible value of x can be 0 plus 9, 0 plus 9, which is then 18 plus x will be 27, which is also divisible by 9. So this implies the possible values of x is 0 and 9, but 9 is not given in the choice. So the correct choice will be C. Okay, let's do problem number 7. Problem number 7 says a 4-digit number 4AB5, 4AB5, this is a 4-digit number, is divisible by 55, then the value of B minus A is. So this number is divisible by 55, which is equal to, so as I said, when it is given that a number is divisible by some number, if that number is not between 2 to 11, always try to factorize that number into factors such that those factors do not have a common factor. So for this 5 by 11, there is only one choice, 5 into 11. So if it is divisible by 55, it must be divisible by all its factors, that is factors of 55, which is in this which are 5 and 11. So this number 4AB5 must be divisible by both 5 and 11. Now the given number is already having its the digit at the units place is 5. So it will definitely be divisible by 5. So we just need to check whether this number is divisible by 11 or not. So we must have 4AB5 are divisible by 11. Now, what is the rule for a number to be divisible by 11? The rule is that the difference of sum of the digits at odd places and sum of the digits at even places must be a multiple of 11 or 0. So this means that if I take the difference of the sum of the digits at odd places and sum of the digits at even places, I have 4 plus B minus A plus 5 is a multiple. Now it can be 0 or a multiple of 11. Is a multiple of 11 or 0. This implies that 9 plus B minus A is equal to 0 or a multiple of 11. Now a multiple of 11 means it can be 11. In that case, if 9 plus B minus A has to be 11, in that case B minus A has to be 2. And which is not given as a choice in the problem. So the other thing is that 9 plus B minus A can be equal to 0. So this means that 9 plus B minus A is equal to 0. This implies B minus A oh sorry, I did something wrong. So 4 plus B minus A plus 5 is not 9 plus B minus A. It will be 1 minus 1. It will be minus 1 plus B minus A. Minus 1 plus B minus A. Okay. Minus 1 plus B minus A must be equal to 0 or a multiple of 11. Now, if so one choice is that minus 1 plus B minus A is equal to 0. This will imply that minus 1 plus B minus A equals to 0, which implies B minus A is equal to 1. So this is one choice of the value of B minus A, which will make the number divisible by 11, because 4 plus, because minus 1 plus b minus a will become 0. Now, what else can the value of b minus a be? Now, this value, this result, that is the difference of the sum of the digits at odd places and the sum of the digits at even places, which is minus 1 plus b minus a, this can be either 0 or a multiple of 11. Let's try to see whether it can be a multiple of 11 or not. If it is 11, then the value of b minus a must be 11 plus 1, which is 12, which is not there in the given choice, and hence any further multiple of 11 will not give a proper solution of b minus a, because any other multiple of 11 other than 11, so let's say if it is 22, then b minus a will be 22 plus 1, that is 23. So it will keep on increasing. So definitely b minus a equals to 1 is the choice, that is the value of b minus a will be equal to 1, and the correct choice is B. B is the correct choice. Okay, let's do problem number 8. Find the greatest values of P and Q so that the odd number, the number is 7, P, Q, 2, Q is odd, is divisible by both 3 and 5. It is given that this number is odd, and we have to find the greatest values of P and Q such that this number will be divisible by both 3 and 5. Now, and also we know that this number is odd. This will imply that a number is odd if the digit at the units place is odd. So we must have Q is odd. The digit Q must be odd. A number is odd when the digit at the ones place or at the units place is a odd digit. So we can clearly see that Q is odd. Now it is said that the number 7PQ 2Q is divisible by 3, is divisible by 3. It is given that it is divisible by both 3 and 5, is 3 and 5. Okay. Now let's say it is divisible by 5. It is divisible by 5. This will imply that Q must be, we know that a number is divisible by 5 only when the digit at the units place is either 0 or 5. So this implies Q is 0 or 5. Now Q cannot be 0. Q cannot be 0 because we already know that Q is odd. So this fact implies that this fact and that Q is odd implies that Q must be equal to 5. So we know that Q is 5. Now we have to find the value of P using the fact that the number 7PQ 2Q is divisible by 3. So we now have that 7P and we know Q is 5. So 7P 5 2 5. This is divisible by it is given that the number is divisible by 3, divisible by 3. Now a number is divisible by 3 when the sum of its digits is divisible by 3. So this implies we will have 7 plus 5, P plus 5 plus 2 plus 5 is divisible by 3. This implies 10, 12, 19 plus P is divisible by 3. So what can the value of P be such that 19 plus P is divisible by 3? There could be many values. Let's see. Now the P is a digit. Its value is it can have values from 0 to 9. Now the next value after 19 which is divisible by 3 is 21. So 19 plus p is 21. That will make p equals to 2. So if p equals to 2, then 19 plus 2 is 21. That will be the a number which is divisible by 3. So p can be 2. P can be 2. It is asking, the question has asked the greatest values of p and q. Now q is having having a single value of 5. Q will not have multiple values because it is found that q has to be equal to 5. Now it is now depending on the values of p, we must select the greatest value of p. Now one possible value of p is equal to 2, which will make 19 plus p divisible by 3, and hence the number will be divisible by 3. Now what can be any other value of p such that 19 plus p is a multiple of is a divisible by 3? It can be those values are 2 plus 3, 2 plus 3, and 2 plus 3 is 5, again 5 plus 3, or you can say 2 plus 3 plus 3. Now you cannot have 2 plus can we have 2 plus 3 plus 3 plus 3? No, p is a digit. It can have values from 0 to 9. So we cannot have further 2 plus 3 plus 3 plus 3, because that will exceed 9. So we can see that p can have values 2 and 5 and 8. 2, 5 and 8, and this implies that max of p is equal to 8. So this implies that p is equal to 8 and q we know is 5. So this must be the value of p and q. So the choices will be the correct choice will be A. Correct choice is A. Okay, let's do problem number 9. It is given that which of the following is divisible by 33. Okay, we have to check which of the three numbers is divisible by 33. So n, we know that n, a number where n is any number, is divisible by 33, which is equal to 3 into 11, implies that n is divisible by 3 and 11. Okay. Now we have to check individually all the numbers whether they are divisible by both 3 and 11 or not. If I check the choice A, 1, 3, 6, 9, 6, is it divisible by 3? We know that a number is divisible by 3 when the sum of its digit is also divisible by 3. So 1 plus 3 plus 6 plus 9 plus 6, this is equal to 10, 25, 25 are not divisible by 3. This number is not divisible by 3, and hence the number 13696 is not divisible by 3, and definitely it will not be divisible by 3 into 11, because any number which is divisible by 33 has to be divisible by both 3 and 11. So choice A is an incorrect choice. So let's see B, the choice B, the number is 185 and 45. Let's see what is the sum of its digits. 1 plus 8 plus 5 plus 4 plus 5. This is equal to 13, 14, 18, 23. 23 is not divisible by not divisible by 3. So definitely 18545 is not divisible by 3, so it will not also be divisible by 33. Okay, let's see the number given at choice C. The number is 27036. Let's see what is the sum of its digits. We have 2 plus 7 plus 3 plus 6 is equal to 9, 12, 18. And this is divisible by 3. This is divisible by 3. Now we also need to check whether this number is divisible by 11. Only then we can say whether this number is divisible by 33 or not. This number 27036 is divisible by 3. Okay. Now to check whether this number is divisible by 11 or not, we have to find the difference of the sum of the digits at odd places and sum of the digits at even places. So this will be 2 plus 0 plus 6 minus 7 plus 3. This must be divisible. This value must be divisible by 11 or equal to 0. Then we can say that this number 27036 will be divisible by 11. Now this implies the value is 8 and 8 minus 10, that is minus 2. Minus 2 must be divisible by 0 by 11. Minus 2 is not minus 2 has to be divisible by 11, or it could be 0. So we are getting the minus 2 is not divisible by 11. So this number is not divisible by, even though this number is divisible by 3, it is not divisible by 11, and hence we can say that this number is not divisible by 33. So none of the numbers is divisible by 33. So the correct choice is D. D is the correct choice. None of this. Okay. Let's do the last problem, which is problem number 10. It is given that a number that is 1 by 212 is divisible, is a multiple of 3. Is a multiple of 3 means it is this number is divisible by 3. Then which of the following values y can have? We have to find the possible values of y such that this number is divisible by 3. So this is divisible by 3. So this implies we know that a number is divisible by 3 when the sum of its digits is also divisible by 3. So we can say that 1 plus y plus 2 plus 1 plus 2 is divisible by 3. So this implies y plus 3, 4, 6. Y plus 6 is divisible by 3. Now we have to find all the possible values of y such that y plus 6 will be divisible by 3. So this implies what can the values of y be? Y can be 0. Y can be 0, and y is a digit. It can have values from 0 to 9. So we can clearly see that y can be 0, because in that case y plus 6 will be equal to 6, which is divisible by 3. Now once you have found one such number, and we are checking whether y plus 6 is divisible by 3 or not, we will keep on adding 3 to the first solution. That is, the first solution is y equals to 0. Then obviously the next solution will be 0 plus 3, and the next solution will be 0 plus 0 plus 3 plus 3, and the next solution will be 0 plus 3 plus 3 plus 3. because the possible values of y will lie from 0 to 9. So this implies the possible values of y are 0, 3, 6 and 9. 0, 3, 6, 9. So the correct choice is D. D is the correct choice. Now let me go back to the question which I could not solve, and I left it with a question mark, which is this number, which is this problem number 3, where it says that AABB is a 4-digit number and also a perfect square. Then the value of A plus B is. Now, sometimes it is possible to answer the question by seeing the choices. You will apply, you will verify the choices individually and see which choice is can be a possible solution of the given problem. Now, if you consider the choice A, uh, the problem has asked the value of A plus B. Now, if A plus B is equal to 12, then we have two choices. Either A is 1, B is 2, or A is 2 or B is 1. So let me solve. But before that, before checking the choices individually, I was trying to apply the concept of general form of a number to see whether what can the values of A plus B, or if we can find the individual values of A and B uh, such that AABB is a perfect square. AABB is a perfect square. Now AABB 1000A plus 100A plus 10B plus B. Now from this expression 1000A plus 100A plus 10B plus B, it is not really helping us to know what can the values of A and B be such that this whole expression is a perfect square. Now what can the possible units digits of a perfect square be? If a number is a perfect square, what can its unit digits be? What are the possibilities of its unit digits? It can be 1, because a number ending with 1, if you take its square, the square will also end with the number 1. So 1 is a possible choice. So the possible choices of B, no, yes, the possible choices of B, because AABB is a perfect square, are B can be 1, B can be, if the number ends with 1, its square will end with 1. If the number is 2, its square will end with 4. So if a number is ending with 3, its square will end with 9. If a number is 4, its square will end with 6. If a number is 5, its square will end with 5. If a number is 6, 7, it will be 9. 8, it will be 4. 9, 81. Okay. So these are the possibilities of the digit B. Since AABB is a perfect square, and we know that any perfect square, its ending digit should be one of 1, 4, 9, 6 or 5. Okay. Now 2 cannot be a choice. 2 cannot be now. Okay. So it is asking the value of A plus B. Okay. A plus B. Now if B is 1, and now this is a kind of trial and error method. If B is 1, so the possibilities of B are 1, 4, 9, 6, 5. Now if B is 1, if B is 1, then definitely we are if B is 1, then let's check whether the choice A can be a solution or not. So if B is 1, choice A 12 means that A plus B is equal to 12. So if B is 1, then A, if B is 1, then A is coming out to be 11, which cannot be the case because A and B are digits. Their values are from 0 to 9. So choice A is right away eliminated because uh, uh, mm, because we are considering the fact that we are considering B equals to 1. Now we can have values from 1, 4, 9, 6 or 5. If you take B equals to 1, then considering B equals to 1, we are checking whether which choice can be a possible solution. So choice A, it is given 12. That means A plus B equals to 12. Now B is 1, then A is equal to 11. This cannot be the case. So with considering B equals to 1, A is the incorrect choice. So choice B, if we consider choice B, if B is 11, choice B, the value is 11, which means A plus B equals to 11, and we know that B is 1. Now if B is 1 and A plus B is 11, that means A equals to 10. Now A cannot be 10, so choice B is also eliminated. If B equals to 1, then choice A and B are eliminated. What about C? C is 10. Now if B equals to 1 and A plus B equals to 10, this means that A equals to and A plus B equals to 10 implies A is equal to 9. So A equals to 9 and B equals to 1. In that case, we are having A plus B equals to 10. Now we need to see whether if A equals to 9 and B equals to 1, we are getting the number as 9, 9 and 1, 1. And we have to see whether these whether 9911 the number 9911 is a perfect square or not. Now this, if you do a little bit of factorization, this will divide by 11 and it will be 901. Now 8, 21, 8. So 4-digit number and also perfect square, then the value of A plus B is and also perfect square. The number is given as AABB. So the first two digits are same and the last two digits are also same. How can this fact be utilized to solve the problem? And it is a perfect square. No, I don't think I can solve this problem because nothing really is coming into my mind. Whatever knowledge I have regarding the on the chapter of playing with numbers, I don't think I will be able to solve it. So sorry I couldn't solve the problem number 3. If you can solve it and let me know in the comment section, I will appreciate that. Possibly I will try to solve this problem offline, and if I can solve it, I will come up with this with the solution in the next video, that is set 2 of on this chapter, set 2 of 10 good problems on this chapter, playing with numbers. So with this, with one failure of solving a problem, that is problem number 3, So I was able to solve 9 problems. With this, it comes to an end in solving these 10 set of problems for the set 1 on the chapter of playing with numbers. I hope these problems will give you a good practice of evaluating your understanding on the chapter of or the concepts of the chapter of playing with numbers. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. Very soon I will come up with the next set of 10 good problems on this chapter, that is playing with numbers. So please stay tuned for that. And in the other playlist, that is CBSE Maths 8 RS Agarwal, I will start the next chapter, which is let me quickly check. It is about algebraic expressions. I think operations on algebraic expressions, which is the next chapter that I will start in the playlist CBSE Maths 8 RS Agarwal. So that's it for this video. I'm sorry I couldn't solve one problem. I will try to solve it offline and come up with the solution in the next while providing the next set of problems, next set of good problems, HOT problems on this chapter playing with numbers. So thanks for watching, and until the next video, take care and bye.